Now, a problem can occur for the method of undetermined coefficients. And so that problem occurs when the initial guess for the y particular solution is one of the homogeneous solutions, either y1 of x or y2 of x. In that case, you must multiply the particular solution by an x until you are your guess no longer contains y1 or y2. So let's go through some examples here. So let's actually start with this middle one. So right, I've got y double prime minus 4y prime minus 21y equals 4 times e to the 7x. Right, so normally you would guess that your y particular is going to equal some unknown constant times e to the 7x. The problem is that won't work, right? We wanted to get e to the 7x on this side, and this constant coefficient, whatever, so we normally guess a times e to the 7x, but there's going to be a problem because e to the 7x is one of the homogeneous solutions. Right, so let's just do that really quick. I'll squeeze it in down here. Let's say we guess, so we have this difference equation, y double prime minus 4y prime minus 21y equals 4 e to the 7x, right? We're trying to solve that, and we're going to make these all particulars, right? Because we're plugging in y particular equals a e to the 7x. But if we do that, all right, so y particular double prime, that's going to be, 7 times 7. It's going to be 49 a e to the 7x. Then I have minus 4 y particular prime. Y particular prime is 7 times a times e to the 7x. So I have negative 4 times 7, so minus 28 a e to the 7x for this middle term. Then I have minus 21 times y particular, which is just a e to the 7x. So minus 21 a e to the 7x. And we want that to equal, and I put a question mark here because it's not going to work, 4 times e to the 7x. Right, but if we add these together, I've got 49 minus 28 minus 21. Well, that's 49 minus 49. There's 0a e to the 7x on this side. And there's no way we can pick a to get 0a e to the 7x equal to 4 e to the 7x. It just won't happen. So this was a bad guess. It didn't work, but there's a way to fix it. So this guess, it won't work here, but what you can guess is equals a times x times e to the 7x. All right, so it's kind of a weird reason why it works, but the kind of short answer is it works because it works. But you get a times x times e to the 7x. X times e to the 7x is no longer one of the homogeneous solutions. So then you can this one will actually work if you plug it in. It's pretty cool. But that's what you guess, a modified guess from what you normally would when the right-hand side, when your guess actually contains one of the homogeneous solutions. All right, so that's the idea. So let's go and do it for this one up here. Well, okay, I have y double prime plus y prime equals 2x cubed minus 1. My homogeneous solution is actually, it's e to the 0x plus c2 e to the negative x. E to the 0x is just 1, so we get c1 plus c2 times e to the negative x. Normally, you would guess y particular equals, this is a third degree polynomial, so we would normally guess, and I'm leaving a little space here for a reason, but we normally guess a x cubed plus b x squared plus cx plus d. But that will end up with a problem because d is one of the homogeneous solutions, right? D times 1, this is c times 1. And so if we actually guess this, we won't be able to solve for the right-hand side. Unless, no, I don't think we'll be able to solve for the right-hand side no matter what. Maybe in some silly case. So instead, you take your normal guess, and you multiply the whole thing by x. Right, even though x cubed and x squared and x aren't one of the homogeneous solutions, the d times 1 is one of the homogeneous solutions. So we're going to multiply the whole thing by x, and then this one will actually work. We'll see that we'll actually do this explicitly in an example after this video in the playlist. All right, there's a couple more left. So here we have y double prime minus 14y prime plus 49y equals 4 times e to the 7x. So, and our homogeneous solution is c1 times e to the 7x, but this is a double root, So we get c1 e to the 7x plus c2 times x times e to the 7x. So normally you would guess y particular is equal to, and I'm going to leave a little space here, so a times e to the 7x. But that's not going to work. That's one of the homogeneous solutions. Okay, multiply by x. Well, that's also not going to work. That's one of the homogeneous solutions. Okay, multiply by x again. And so this is actually the particular solution you would guess, because you multiply by x enough times, it's no longer one of the homogeneous solutions. And you actually plug this one in, it'll actually be able to solve for the right-hand side in this particular ODE. All right, well, last one. So we got y particular equals. Here we're solving for 13 sine 2x. I'm going to leave a little space here. So normally we guess a times cosine of 2x plus b times sine of 2x. But that's a problem. We have a times cosine 2x. That's one of the homogeneous solutions. We also have b times sine 2x. That's another homogeneous solutions. So instead, we're going to multiply the whole thing by x. And that's going to be our guess for y particular. And it'll turn out it works. And you'll actually be able to figure out a and b to solve for the right-hand side. All right, so that's kind of the big problem that can occur in this method of undetermined coefficients. But luckily, it has a nice solution. You just take what you originally guess and you multiply by x, usually, maybe x squared, until the guess that you have does not contain the homogeneous solution. So right, this one's the kind of the weird one, right? This has x cubed, x squared, x. Those aren't in the homogeneous solution, but d times 1 is. This is c1 times 1. So we multiply the whole thing by x, not just the d, the whole thing. In the other cases, right, it's the whole thing too, but it's not as ambiguous, you know. But that's the idea. So we're going to do these examples explicitly, and we're going to actually solve them, and hopefully you can do your homework after that.